Hello viewers, welcome to the first section of the course, Mastering Promises. In this section, we'll start off by understanding and implementing basic promises, then continue with chaining promises and promise handler. We will then proceed to create promise wrappers and then implement promise barriers. Further, we will cancel asynchronous actions and convert a promise into an observable, and finally convert an HTTP service observable into zone-aware promise. Let us now move to the video of the section, Understanding and Implementing Basic Promises. In this video, we will first understand the problem, then execute the function, and then resolve the problem to a value. Promises are very useful in many of the core aspects of Angular. Although they are no longer bound to the core framework service, they still manifest themselves throughout the Angular's APIs. The implementation is considerably simpler than Angular 1, but the main rhythms have remained consistent. You can refer to the code, links, and a live example of this at ngcookbook.herokuapp.com. Before you start using promises, you should first understand the problem they're trying to solve. You can classify the concept of a promise into three distinct stages. Initialization. Initialization means you have a piece of work that you want to accomplish, and you want to define what should happen when this work is completed. You do not know whether this work will ever be completed. Also, the work may either fail or succeed. The second stage is pending. You have started the work, but it has not been completed yet. Third is completed. The work is finished, and the promise assumes a final state. The completed state assumes two forms, resolved and rejected. These correspond to success and failure, respectively. There is more nuance to how promises work, but for now, this is sufficient to get into some of the code. Now we will see how to do it. A promise implementation in one of its simplest forms is. Here promises are instantiated with the new keyword. The function passed to the promise constructor is a piece of work that is expected to execute asynchronously. The formal term for this function is executor. The promise constructor doesn't care at all about how the executor function behaves. It merely provides it with the two resolve and reject functions. It's left up to the executor function to utilize them appropriately. Note that the executor function doesn't need to be asynchronous at all. However, if it isn't asynchronous, then you might not need a promise for what you are trying to accomplish. When the function is executed, internally it understands when it is completed. However, on the outside there is no construct that represents the concept of run this when the executor function is completed. Therefore, its first two parameters are the resolve and reject functions. The promise wrapping the executor function is in the pending state until one of these is invoked. Once invoked, the promise irreversibly assumes the respective state. The executor function is invoked immediately when the promise is instantiated. Just as importantly, it is invoked before the promise instantiation is returned. This means that if the promise reaches either a fulfilled or a rejected state inside the executor synchronously, then the return value of the new promise will be the freshly constructed promise with a resolved or rejected status, skipping the pending state entirely. The return value of executor is unimportant. No matter what it returns, the promise constructor will always return the freshly created promise. This code demonstrates the 5 different examples of ways that a promise can be instantiated, resolved, or rejected. In the first line, this executor is passed resolve and reject, but is effectively a no-op, so the promise P2 will forever remain in the pending state. In the next line, the executor invokes resolve immediately, so P2 will be transited directly to the fulfilled state. In the third line, the executor invokes reject immediately, so P3 will be transited directly to the rejected state. A transition to the rejected state will also throw an exception. The exception is thrown after the executor completes, so any logic after the invocation of reject will still be executed. The console.log prints before the exception is thrown. This executor invokes resolve immediately, so P4 will transition directly to the fulfilled state. Once a promise exits the pending state, it cannot change again, so even though reject is invoked afterwards, the final state of P4 is still fulfilled. This line says that the executor assigns its resolve function to a variable in the encompassing lexical scope, so it can be called outside the promise definition. Now these will state that state of P5 is pending, and this line will state that. With what you've done so far, you will not find the promise construct to be of much use. This is because all the preceding code accomplishes is the setting up of the state of a single promise. The real value emerges when you set the subsequent state handlers. A promise object's API exposes a then method, which allows you to set handlers to be executed when the promise reaches its final state. P1 is a simple promise to which you can attach handlers. Here, P1 exposes a then method, which accepts a resolve handler, onFulfilled, and a reject handler, onRejected. OnFulfilled is invoked when resolve function is invoked. OnRejected is invoked when reject function is invoked. If left here, P1 will forever remain pending. Using the new keyword still allows you to call a method on the return instance, so defining the then handlers immediately is allowed. This instantly resolves P2. This method will immediately be invoked after the P2 executor invoking resolve, whereas this line instantly rejects P3. Then, this second method will immediately be invoked after the P3 executor invoking reject. If you don't require use of the resolve handler, catch method allows you to define just the error handling. Executor parameters can be captured outside its lexical scope for later invocation. After this, it will show resolved. Let's discuss how this works. Promises in JavaScript confer to the developer the ability to write asynchronous code in parallel with synchronous code more easily. In JavaScript, this was formerly solved with nested callbacks, colloquially referred to as callback hell. A single callback-oriented function might be written as shown, a generic asynchronous callback function. This block of codes shows that async function will perform some operation that may succeed, may fail, or may not return at all, any of which occurs in an unknown amount of time. The pseudo response contains a success boolean and the returned data if successful. If the application does not demand any semblance of in-order or collective completion, then this code will suffice. Async function succeeded, handle data appropriately. Async function failed, handle appropriately. This is almost never the case though. Often your application will either demand that this data is acquired in a sequence or that an operation that requires multiple asynchronously acquired pieces of data executes once all of the data has been successfully acquired. In this case, without access to promises, the callback hell emerges. Foo, bar, baz can now all be used together. Combinatoric function foo, bar, baz. This so-called callback hell here is really just an attempt to serialize three asynchronous calls, but the parametric topology of these asynchronous functions forces the developer to subject their application to this ugliness. An important point to remember about promises is that they allow you to break apart a calculation into two parts, the part that understands when the promise's execution has been completed, and the part that signals to the rest of the program that the execution has been completed. Decoupled and duplicated promise control. Because a promise can give away the control of who decides where the promise will be made ready, multiple foreign parts of the code can set the state of the promise. A promise instance can either be resolved or rejected at multiple places inside the executor. These are pseudo methods, each of which can be called independently and asynchronously, or not at all. A promise instance can also be resolved at multiple places outside the executor. Again, these are pseudo methods, each of which can be called independently and asynchronously, or not at all. Once a promise's state becomes fulfilled or rejected, attempts to reject or resolve that promise further will be silently ignored. A promise state transition occurs only once, and it cannot be altered or reversed. Next is resolving a promise to a value. Part of the central concept of promise constructs is that they are able to promise that there will be a value available when the promise is resolved. States do not necessarily have a data value associated with them, they only confer to the promise a defined state of evaluation. State can be defined with resolve, reject, resolve my data, reject my data. An evaluated promise, resolved or rejected, is associated with a handler for each of the states. This handler is invoked upon the promise's transition into that respective state. These handlers can access the data returned by the resolution or rejection. Here, the console.info is the resolve handler, and the console.error is the reject handler. 123 reset to demonstrate reject, and reject 456 is error 456. Next is delayed handler definition. Unlike callbacks, handlers can be defined at any point in the promise lifecycle, including after the promise state has been defined. This is the line of code. This line immediately resolves the promise, and this line subsequently defines a handler will be immediately evoked since promise is already resolved. Next is multiple handler definition. Similar to how a single deferred object can be resolved or rejected at multiple places in the application, a single promise can have multiple handlers that can be bound to a single state. For example, a single promise with multiple resolved handlers attached to it will invoke all the handlers if the resolved state is reached. The same is true for rejected handlers. Constant P4 invokes resolve after 1 second. After 1 second, we get called. Private promise members. An extremely important departure from Angular 1 is that the state of a promise is totally opaque to the execution. Formerly, you were able to tease out the state of the promise using the pseudo-private $state property. With the formal ES6 promise implementation, the state cannot be inspected by your application. You can, however, glean the state of a promise from the console. For example, inspecting a promise in Google Chrome yields something like this. Promise status and promise value are private symbols, which are new constructs in ES6. Symbol can be thought of as a unique key that is useful for setting properties on objects that shouldn't be easily accessed from elsewhere. For example, if a promise were to use the promise status string to a key property, it could be easily used outside the object, even if the property was supposed to remain private. With ES6 private symbols, however, a symbol is unique when generated, and there is no good way to access it inside the instance. Wonderful! In this video, we learned about basic promises and also learned to implement them. In the next